Today we're doing lesson 2-7 for geometry, improving segment relationships. So the first example, and just to bring this to your attention, in this lesson you have another postulate added, which is postulate 2.9. It's called the segment addition postulate, which basically says if you have 3 points that are collinear on the same line, if you add the 2 points together plus the next 2 points together, then it's going to be a total of the first point plus the last point. So if I drew a picture, it would look like this. So AB plus BC equals AC. And that would be the segment addition postulate. The ruler postulate, which is also another postulate added here, is basically just talking about measuring with a ruler and being as exact as possible. So we're going to look at the first proof here, and we're going to fill in the blanks. It's having us prove that JL is congruent to KM, or I'm sorry, it's having us prove JK is congruent to LM, and it gives us that JL is congruent to KM. So if we think about just the definition of congruence, the first step here, it says JL is congruent to KM, which is the given. Then the next step, it's JL equals KM. All that's indicating is that the sign in between the JL and the KM for the first step means congruence. So we're going to write for our reason definition of congruence, or congruent statements is fine. Then we go to the next statement, and we have 2 blanks to fill in. This is talking about the segment addition postulate. So if you look at the line up here, it says JK plus KL equals what? So if we do the segment addition postulate, that's going to be JL. And then same idea, KL plus LM would equal KM. And again, all this is talking about is the segment addition postulate. So that's how we would fill in those. Now, if you notice what they've done for the next step, they've taken out, basically they've taken out what each segment addition was for part C, and they've put them equal to each other. So part C, it said JK plus KL equals JL, and KL plus LM equals KM. All that did is take out the JL and KM and make JK plus KL equal to KL plus LM right here. So if we took that out and all we did was replace something, this is going to be using substitution. Then we go to the next problem, or the next part, and that fills it in completely for us. Notice that they're subtracting KL from both sides, which is going to make now JK left equal to LM left. And if you notice that the last step where it says JK is congruent to LM, all they've done is kind of like what we did in the first 2 steps. They've indicated that when it has that symbol that it is congruent. So we would just fill in those parts to the proof. And the next example, we're going to make a proof. So we're going to do a 2-column proof, and we're looking at the picture here. It's kind of hard to tell here, but this is a Q right here. and then you have an RS. But what it tells us is that you have a carpenter cutting 2x4 boards to basically the same length. He uses or cuts one board and uses that as a pattern to cut a second board congruent to the first, and he's going to continue to do that. So similarly, he uses the second board to cut a third board and the third board to cut a fourth board. So we need to prove that the last board cut has the same measure as the first. So we're going to go through and make a proof proving that. So we're given that KL is congruent to MN. You can see that they're both on the floor here. So we're going to start with that. We have statements. And reasons for our two-column proof. And we're going to start with what we know, that KL is congruent to MN, which are both the boards on the ground there. Also, we know that MN must be congruent to one of the other boards that he's cut. So we'll do MN is congruent to PQ. And then we know that PQ has to be congruent to RS. Whoops. So we do PQ is congruent to RS. And those are all the boards that were given, because one board in the first part is congruent to each board after that. So that's our given. Our next part, we need to prove that the first board is congruent to the last board, so we'll just go by our list. So we need to prove that KL is congruent to RS, because KL is the first board and RS is the last board listed. So if we do that, we're going to be using the transitive property here, because we need to, or you can notice actually that you have MN repeated twice in the givens and PQ repeated twice in the givens. So if we do if we follow the first part of my proof, we would say that KL is congruent to MN. We know that. But by the transitive property, we could take out the MN, because notice these two statements have MN alike, and we could say KL is congruent to PQ. And since we took out the middle, that's called using the transitive property. Okay, and then we're one step closer. If we use the transitive property again, we could also say MN is congruent to RS, because both are congruent to PQ. So we have, again, the transitive property. Now, if we look at our statements, we're trying to prove that KL is congruent to RS. So what we need to do here is think about how we can get KL now congruent to RS. We're going to go to the next page. So we can actually use the transitive property one more time here, and we would have, since PQ is congruent to MN and KL is also congruent to MN, that's why we put KL together with PQ. But then PQ is congruent to MN and PQ is also congruent to RS. So we could take out the MN and the PQ and make KL congruent to RS. And that's another transitive property. So we're actually using the transitive property 3 times, and then we have our proof, which is what we said in the beginning, we wanted to do KL congruent to RS, the first board congruent to the last. So that would be the definition of congruence, because if you notice the difference between my last step and this step, I just took the congruent sign off and just made it equal to, because it didn't necessarily say congruent to, it just said has the same measure as the first. So that would be the end of my proof, and that concludes lesson 2-7.